This is Smarter Cars, and I'm your host, Michelle Kairouz. Welcome to Season 6 of the podcast. Today we're talking with Jameson Detweiler, the president and co-founder of Fantasmo, a company that makes 3D maps and provides hyper-accurate positioning services for micromobility vehicles. Jameson, welcome to the show.
Thanks. Happy to be here.
Can you start by telling us what Fantasmo does?
Sure. So Fantasmo is a next generation maps platform. We're basically building hyper accurate 3D maps to enable next generation applications, which includes everything from augmented reality to autonomous robotics and one of our favorites, micromobility.
Some of our listeners may have some familiarity with HD maps from the autonomous vehicle space. Can you tell us how what Fantasmo does is different from some of the mapping that's done in the autonomous vehicle space?
Sure. So we primarily focus on non-automotive applications and focus also on urban areas. The constraint that we use is we're trying to create maps for applications that are under 20 miles per hour. So that's sidewalks, bike lanes, and even inside of buildings. One of the key issues in these types of environments is that the GPS errors is often actually much larger than the device itself, whether it's a phone or it's a scooter, or it's a robot, or it's a person walking around. So it's hard to place a device or a person with a phone on a sidewalk or anywhere specific. So we've developed a technology that uses just images to be able to tell exactly where a device is, down to 20 centimeters or less in effectively real time. Most HD maps are building 3D models of cities in very similar ways, and they're building positioning technologies, but it tends to be a combination of sort of ADAS types of features, and sometimes they're doing sort of positioning from the 3D data, where they're actually using the LiDAR and other sensors or the stereo cameras to do that. We just work with simple commodity off-the-shelf cameras on everything from your phone to a Raspberry Pi camera.
So you're saying two things. One, that you're using camera images to locate where these vehicles are in a way that's more precise than GPS, but you're also talking about creating maps. Those sound like two different things. One being that you go out and map an area and learn the ground truth, and the other is a camera looking out from a scooter or a robot or other device and deciding where it is on the spot. How do those two things fit together?
So one way to think about it is that instead of sort of a GPS transmitter or any sort of wireless transmitter, the actual ground truth map data is what we're using to locate the device. So you actually triangulate effectively off of the map itself. So we go through cities, we walk around them with custom built hardware that has two Velodyne VLP16 puck LiDARs on them, which you see in a lot of robots and autonomous vehicles. And then there's 6 cameras on there. These are all time synced and has a GPS and Wi-Fi and other sort of signal mapping on there. But this allows us to create a dense 3D model of a city that's going to look like HD maps sort of in the core data layer from many other providers, whether it's here or someone else. What we're able to do from that too is build a 3D visual fingerprint. And you can think of it in some senses as like a QR code across the entire city. And from that, instead of using a satellite to get the position, we actually are able to use the city as sort of a giant QR code of sorts to get the position of the device. Today, that's the primary thing that we offer is really about position. We are also building in more traditional maps products around the 2D and 3D data and the information associated with it. You could use it for navigation, things like that. But today we are very much focused on positioning and helping use that positioning for understanding where a device is. And one of the other interesting things we're doing is around parking enforcement for micromobility applications.
Do you sell software, or is there a hardware component that's necessary if someone wants to use your maps on a scooter or robot of some sort?
So we have a web-based API. So we have software that allows you to just basically send an image to the Fantasmo servers and we'll tell you exactly where that is. This can be used on a mobile phone, and that's where we're seeing the implementation today for doing parking enforcement and the end of the ride camera for micromobility applications. We have a hardware-based solution that does integrate directly into IoT modules of micromobility vehicles and robotics that is under development now and will be starting to roll out in Q3 of this year in pilots.
So today what you're offering is stationary confirmation of where the scooter ends up, but in the future, you're looking to add an IoT module that would allow you to track the scooter as it's actually moving?
So we're not actually developing a full IoT module. We'll have dev kits available for that, but really it is our software running on custom built IoT modules that typically operators are building in-house themselves. Really, they need to add a vision processing unit, specialized chip for running these types of algorithms, a camera, and some onboard memory for storing the maps. And so yes, that'll run all on there. It'll basically deliver a continuous sub 20 centimeter position directly on the device in real time. And along with that, it'll also have a detailed underlying map associated with it. So you'll know from the position if the scooter is in a bike lane, if it's on a sidewalk, if it's blocking a curb cut for some reason on sidewalk, all of that will be there directly on the device, available to the operator to then determine how that scooter operates or that bike operates based on that information.
If you have a camera on the scooter today and you're just driving a scooter and the camera's looking out and seeing where it is, how will that differ from what you're proposing, which is to have a pre-installed map with the ground truth information about the city combined with the camera? How will those results be different in your view?
So if you have a camera on there and nothing else, you're just kind of logging those images, you can correlate them back to perhaps the GPS signal you have on there. There are some companies out there that are building sort of modules for doing machine learning driven classification of what it's seeing. So I can say, hey, I see a road, I see a sidewalk, and things like that. But what it doesn't have is sort of specific intelligence of exactly where it is on the map itself. And it doesn't have a high level of accuracy in that model. So for us, because we go through and we actually generate the maps from the ground, we have a very high level of accuracy and high level of detail of the city itself. We also have detailed sidewalk data, which is pretty rare because most data is collected from vehicles. And you have just occlusions of the sidewalk from vehicles that are parked. And so for us, we're able to take those images that come in and actually know exactly where they are, right? Your GPS may think that you are 15 feet to the right, but we know that you are precisely within this sort of 20 centimeter range. And then we're able to say, based on this position and the map that we generated, we know that you are in this bike lane and you're in this area of the bike lane and that there's an intersection coming up and all of that sort of deep intelligence that ultimately is what you're going to need to build autonomy into these types of things. It's that data layer that without that, you're not going to be able to enable truly autonomous decision making that doesn't require a remote operator.
How do you add the semantic layer to your maps that might say, well, this bike lane travels in this one-way direction, or other information that if the robot is driving itself would need to know?
So we actually have a full labeling pipeline in-house. It's a combination of people and sort of automated labeling tools. And so we go through there and basically our objective is if it's bigger than 6 inches, we want to be labeling that in there. So it's a very high level of granularity and detail in the map itself.
I read a little bit about what you call your camera positioning standard or something like
CPS,
that.
camera positioning system. Yeah. Yep.
System. Yeah. And tell me what that's about and what the 6 degrees of freedom are.
Sure. So yeah, this is the positioning technology that we've been talking about. So it's building a new type of technology that does use images to get position. Don't even necessarily need to have a GPS in order to enable that. So if we've mapped that area from the ground, then we can do that. And in terms of 6 degrees of freedom, this means that in addition to sort of the X, Y, and Z coordinates, we know exactly where it is on the globe and the elevation. We also know the orientation of the device. So we know yaw, pitch, and roll would be the terms, right? So which is something that's not even possible to get from the GPS itself.
And so as you're thinking about building out this positioning system and the granularity that you're able to provide without GPS, using camera images, what do you see in the future as possible use case for it? You mentioned autonomy. Are you envisioning being able to autonomously reposition scooters or make your service available to delivery sidewalk robots? Like, how are you thinking about this going forward?
Yeah, absolutely. I mean, we don't have any plans to get into the actual sort of autonomy side of the business. So we're not trying to tell them how to navigate, right, and handle that. What we can do is we can feed in the data layer into a company that is basically trying to do the autonomous navigation component. Sidewalk robotics is a very clear piece of that as well, that we can help with. But we can also even help with essentially your Uber Eats delivery as well. Because when they get off their bike or out of their car and they're trying to find the door to your house, that's where they typically get lost. It's not actually from the restaurant to your general area, it's when they're trying to figure out where your doorbell is.
Your map system is a layer that would be used in autonomy, but you're not doing the other aspects of things involved in actually driving the vehicle.
In terms of the actual driving the mechanics of the system, right? So the controls of the robot we're not doing, but the actual, hey, what's my directions and where's the curb and how I navigate through there? Yes, that part would fall into what we're building.
When you are providing service to a scooter operator, are you able to then coordinate with the scooters so that if someone drives up onto a sidewalk and they're not supposed to be there, that you could implement that at a control level to say, okay, now we're going to reduce the speed to 5 miles an hour, or we're going to kill the scooter's engine, or that kind of thing? Would that be something that your service would do?
Absolutely, we can support that. So what we're able to do with that embedded system where it runs on the IoT module is in real time, we can feed back, hey, this scooter actually just crossed into a zone where it needs to slow down to 5 miles per hour. And so then they would take the controls from there. Same thing with parking. It'd say this person has just come up to a sidewalk, and then they could either stop it immediately, they could trigger a warning, or they could wait 5 seconds to see if they leave and then slow it down. So that's entirely up to the operator who's doing the implementation. But we provide the real-time feedback that's needed to be able to do that type of enforcement and do it with a very high level of accuracy to a point where it's safe enough to slow down a scooter. Part of the issue when you look at some of the other solutions that are doing sort of a machine learning type of detection is that they can be relatively accurate in that you're going to 90% of the time say that this is a sidewalk. The problem is that if during that 10% of time somebody happens to be turning through a busy intersection and it accidentally classifies something, you can't rely on that information to actually really slow down a scooter in that way.
How do you think about the costs involved in creating your maps and what that value proposition is? You've mentioned that other folks are trying to do this just using the camera images without the mapping. And I'm just wondering, how much cost does it add for you to go and do these maps of every city, and how you see that value proposition?
Yeah, so the mapping for us, I mean, generally it ends up kind of paid for by one customer within a year. So our costs are quite low in the way that we're doing them. And that's one of the key things that we've been able to innovate on is we've kind of created a pipeline and a process for doing this mapping and labeling by bringing all of it in-house, including the hardware to do it. That allows us to do it very fast and in a very cost-effective way. And of course, the maps too are shared across customers. So once we've mapped the city one time, we don't have to go do it again for another customer.
So today, what your product does is to help micromobility companies identify whether a scooter or other vehicle is properly parked based on the information that you provide from your maps. Are there other features or use cases based on what you have today, or do you need the IoT kind of implementation to do things when the vehicle's moving?
So while it's moving, yes, you need to have a camera available on there. And so you'll need to have the camera on the device.
And how are you pricing your service? Is it per vehicle in a fleet or per customer? How are you thinking about pricing as you move forward and map different cities?
Sure. So the pricing on the parking SDK, as we call it, to help make sure that the scooters are parked legally, we do on a basically on a per session basis. So each time it's parked, we charge them there. And the pricing of that varies from market to market and the total volume that we're working with an operator on, but it gets down into the pennies range per ride. On the embedded system, we don't have pricing available for that today, but it essentially will likely be a licensing model on a per device basis.
So you mentioned that there's an API and that when someone parks, they're basically calling into your web service to make a determination. Are you envisioning computing on the edge on the vehicle ultimately, or does it require connectivity in order to use your service?
Yes. So the solution that we're developing to run directly on the scooter will run entirely on the edge. So we have a reference design and recommended specs that our software will run on. So this will be built directly into the IoT module. No connection to the internet will be necessary in order for that to work. You'll just want to get periodic map updates that are going to get loaded onto there, which is going to happen during a service event or during a charging event or something like that. These scooters are connected to the internet relatively often, and the map updates will need to happen every month or a couple months.
Speaking of updating, I know that with HD maps in the autonomous vehicle space, one of the key problems is keeping the maps super updated because somebody changes a stop sign to a light or adds a bike lane where there wasn't one or what have you. How are you thinking about updating and frequency, especially since you're dealing with not big roadways, but smaller spaces like bike lanes that might get added or sidewalks that might change or a curb cut? How do you think about updating your map?
Sure. So when we have the maps loaded onto the scooters or other devices, in addition to basically storing that map, local storage is also used to save images from the riding sessions. And when there's a exchange of data, when the map is updated, those images get sent to us. All personal information is removed at the client side. So on the scooter itself, faces and license plates and things like that get blacked out. We don't have any interest in that. Don't want any of that information to come back. And so we take that out of there. And then we take those images and we can run them basically through our software pipeline and do a change detection, right? So if there is a new bike lane that was actually placed, we'll see that as part of our pipeline and then be able to update that in the map itself.
So you're envisioning going forward when you do have service that is being used on scooters or other vehicles that are moving around, that those images will be compared against the ground truth in your map, and then you'll identify those variances, and that will help you update your map.
That's correct. Yeah. So it's essentially a self-updating map, right? It's sort of an underlying part of using our service is that you need to use those images, because using those images, we're able to then detect when there's a change. We can do that in a mostly automated fashion, but we also can review it with people to see if there's anything that doesn't seem to make sense to a system. And so that way, once we've mapped a city for the first time, we don't actually have to really go out there again. All of our customers' devices in the fields are able to help keep that up to date. And ultimately, where this goes over time, where you'll see this happening as data connections do get faster and you're able to transmit this data on the edge back to a server, or even in the future, potentially on a 5G cell tower, you'll be able to move toward real-time updates as well. So that scooter that's driving around may see cars moving, may see a pedestrian that's headed a certain way, and be able to transmit that information around to the network so it can have that real-time 3D model or HD map, as you might call it.
And are you also thinking about trying to keep tabs in various cities when there are announcements about changes? Like if somebody says we're adding 5 miles of new bike lanes in this city, are you going to proactively go ahead and change the map? It seems like the downside to waiting is that the first guy who goes through doesn't have the benefit of the change, right? It's only afterwards that you notice that something was wrong. Are you thinking about trying to come up with a more human way of updating?
Sure. So, I mean, we are tied into like these public data sources you'll have, right? So we have cities that are putting parking down for scooters. Most of that data is published online. So you can actually get that information, when there's updates. And so we monitor those things to be aware of when a change might be coming as well. And so, yes, we're working on to do that more proactive than that. But the update speeds on that are typically going to be pretty fast, and certainly much faster than you're going to see on a typical Maps app that you're using on your phone.
You mentioned that camera-based positioning can also work indoors and within a building. How is that helpful for locating scooters?
So in terms of the indoor models there, I mean, we typically do that we have customers that use our technology and for specific applications today. So we don't make maps of private buildings available to the network. That's a problem that needs to be solved. You need to be able to access the map of a building for these types of applications. In the future, in your home, you will have a robot that goes around and cleans, and you could have other devices that are operating that way. Ideally, they share a map. Ideally, there's a system that enables that. Those are some of the problems that we think about. So it's not particularly interesting to this, like a scooter company that we work with, because if we do have a map of an office building we have a customer called Good Maps. They help people who are blind and visually impaired navigate through buildings using just a phone. But that map is created specifically for their application, and they're doing that, and that's with the customer's permission, of course, and it wouldn't be something we could share to the scooter company at this point.
So the problem with mapping private buildings is that the owner of the building doesn't really want their map or interior layout shared with the world. And so it becomes a little bit proprietary in that way.
Well, it is proprietary ultimately. I mean, if you look at the way that you have to build maps for indoors, it's got to reflect both the legal and social contracts that we have around private space and semi-private spaces, right? There's an expectation of privacy. There's certainly security concerns and things like that. So you have to have a really granular model in which you're able to share this data in a way that's safe and everybody feels comfortable. When you're a building operator or you're a tenant and you have this and you want to enable this, you typically don't know yet that there's kind of applications that might need this. They're just starting to emerge in a lot of ways. So it will get solved here, but there certainly is a resistance to let that information out. So you have to build a good system to do that where everybody involved is comfortable with the way that it's happening.
I know a number of cities are interested in mapping the curb, and there are some companies that are going around and helping cities map the curb to understand where the car parking spots are and where the curb cuts are and where they might be able to put an Uber drop-off zone or things like that. Is your data something that you could sell to cities to help them understand uses of the sidewalk and the curb in ways that they may not already have mapped?
Absolutely. And I think one of the key things that we do there that's different from many of the other companies out there is that we're actually collecting ground-based centimeters accurate survey data there. So we can tell not just that, hey, there's a curb cut here, we can actually say this is exactly where it starts and where it ends. This is the slope. And if you want to see breakage in a sidewalk from a tree growing underneath it, you can actually get a 3D model of it and understand those pieces. So these are areas where we collect that data and are working on the labeling on that and exposing it. And ultimately, our objective there is to create better, safer sidewalks and pedestrian areas for this. We've got a significant amount of competition today for the curb in cities. And it's an area where this type of data is going to be really important. One of the least mapped areas in the world really is sidewalks. We know a lot about our streets and we even know a lot about sort of open areas. We have some satellites, but when you get into a dense city and you have tall buildings, you don't have a lot of idea of what's actually happening on those sidewalks.
The other thing I think cities are interested in is where the curb is painted. You know, often, at least in the US, the curb might be painted red to indicate no parking, or there might be signs. And sometimes cities don't have a digital representation of every block to say, oh, in this block, there are 3 valid parking spots and then there's 12 feet of red curb. Is that something you can help with?
Absolutely. And ultimately, even if the city does have that information, it's going to be pretty inaccurate. One of the things we've seen in Paris is how often the actual parking spaces, as they're represented in the geodata layers that they share, it's not actually specifically accurate to the spaces themselves. And it makes sense because it's just essentially an estimate of that area. But for us, we're coming in and we get centimeters level of accuracy. So we take that information and go and determine it. And so we can actually get that and share that back, whether it's the painting of that, it's the precise location of a parking space. That's all information that we can share back.
Who are some of your customers today or types by category of company, and how do you see that evolving?
Sure. So we work today with Tier and are rolling out with them throughout Europe. And so they're an incredible micromobility provider based out of Berlin. And this is who we went into Paris with as well and mapped all of the 2,500 plus parking spaces there and working with them on deploying the parking enforcement technology in quite a few markets throughout all their 85 plus markets, in fact. And we are also working with some other micromobility providers, not in a way that we can talk about yet, as well as fun things like we have a Wallace and Gromit augmented reality game that's going live in Bristol, England with a company called Fictioneers. And we work with companies like Good Maps who provide navigation technology for people who are blind and visually impaired. So it's a wide variety of customers. We started out actually as an augmented reality company. And so just saw that this was an underlying key piece of technology to enable all sorts of other applications.
How does your service work with augmented reality companies?
So with augmented reality, you're again in a position where the GPS isn't accurate enough to know where you are relative to sort of the 3D model, right? Because if you think about it for augmented reality, where you want to have a character hiding behind a building or coming around a corner, you essentially need to overlay a transparent 3D model of the real world on top of the physical world. Lining that up is where it's a particular problem to do that in real time on your phone or eventually on AR glasses. And we effectively help with that alignment.
And so how do companies like Pokemon Go or whatever, how do they do it? Do they go out and map themselves?
So Pokemon Go today doesn't really integrate a lot of that sort of 3D detail into it. So essentially the characters that you're interacting with are in limited sessions and they're not spatially aware, right? They make some very simple assumptions that work. A large percentage of the time we're like, oh, if you're standing up, we're going to assume that the floor plane is at a certain level. We're going to project the character on there. But if you threw a pillow at it or you pushed a chair there, or if you did anything along those lines, it's not going to be aware of those things that are happening. But Niantic is certainly building very similar technology themselves and are very public about it to become a AR cloud provider, essentially.
Interesting. I guess we're all living in more and more augmented reality. What does the next year look like for Fantasmo? What are you envisioning and what are you focused on?
We're very focused on expansion throughout Europe to support our work with Tier in areas and cities across the US, and also to get our embedded solution out into the market. So we want to see vehicles out on the road that are actually running Fantasmo CPS and getting that working really well. And just continue to work with people and companies that are building really cool applications, whether it's robotics, augmented reality, micromobility, or anything else that can use a better position. That's what we're focusing on.
Great. Well, thanks so much for coming on the podcast and telling us about Fantasmo. It's super interesting.
Thank you for having me. I appreciate it.
Thanks again to Jameson for joining us. You can find the show notes for the podcast on our Substack publication. It's at smartercars.substack.com. If you're enjoying the show, please leave us a rating or review at Apple Podcasts or wherever you listen to your podcasts. Thanks for listening. We'll see you next time.